Dear A-level students everywhere, hi everyone. Due to our circumstances, my main students that I teach physically, may Allah protect all of you. And I wish and I hope all of you are safe with these circumstances that we are in because of COVID-19 this year. Anyway, so I would like to continue pure mathematics as videos on YouTube for today, starting from today. We finished before this chapter the main trigonometric identities, solving trigonometric equations, simplifying trigonometric expressions, using some identities. We used some identities from P2, from pure 2, and we had learned in chapter 3 new ones. So I wrote to you here all of them to remind you again. There are 6 basic ones: cosecant theta equals 1 over sine theta, secant 1 over cosine, and the old one, sine squared theta plus cosine squared theta equals to 1. And we just finished with 1 plus tan squared theta is equal to secant squared theta, 1 plus cotangent squared theta is equal to cosecant squared theta. Today we'll be learning new identities, and we are in the same objective, the same main objective, which is simplifying and improving trigonometric identities in general. So we'll do a part for today, then we'll be continuing the next parts. First formulae or formulas we'll start with this chapter with. They are called addition formulae, addition identities. First one, of course, we don't need to memorize them, but we will be memorizing some of them by practice. When we do practice, we'll memorize them. Sine the sum of 2 angles is equal to sine A plus sine B. A and B are angles, plus cosine A sine B. Sine the difference equals sine the first cosine the second minus cosine A sine B. Identity 2, or the second identity, cosine A plus B equals cosine A cosine B minus, here we oppose the sign, we converse the sign, minus sine A sine B. Cosine A minus B is equal to cosine A cosine B plus sine A times sine B. The last one, tan A plus B is equal to tan A plus tan B over 1 minus tan A tan B. Then tan the difference is equal to tan A minus tan B tangent B over 1 plus tan A tan B. You take your time reading them, but you will do understand them by practicing, as we'll be seeing in the examples now. Of course, it's a part of the syllabus in Pure 3. We might be asked to prove one of them, one of these identities, using the older or the old identities. Like I did in example number 1. If some of you have P3 books, I wrote to you, if I see some questions meeting the questions in the past papers, so I wrote to you here the number of the question if you have the book. So the first example we'll start with is question 2, page 74 in the textbook, TB for textbook in P3. Using the formula sine A minus B and cosine A minus B that we wrote in the first page, to show that tan difference of 2 angles, tan A minus B. We know, of course, let's prove it and to see how we do some questions. Tan A minus B is equal to sine over cosine the angle. So tan A minus B equals tan, this equals to sine A minus B over cosine A minus B. Then we write for each one, what does it equal to? Sine A minus B equals sine A cosine B minus cosine A sine B. Cosine A minus B, cosine A cosine B, plus, remember, in the cosine, we oppose the sine, plus sine A sine B. Now the most important skills in the proof, we know this, but the proof is more in P3 and P4. We look, what does he want? He wants this term is 1. So what's the idea in this? We make this 1. This is the idea, this is the skill, and this is the idea we start with. How we do this one? How we make this term is 1, as he wants in the result here, by dividing by itself, by dividing cosine A cosine B by itself. So what we have to do? We divide each term by this term. We divide each term by this term, as I did in detail. So I did the first one. Cosine A cosine B dividing by cosine A cosine B, cosine A cosine B, and so on, each term. What will happen? Sine A over cosine A is tan A. Cosine B with cosine B, they cancel each others. Cosine A with cosine A cancelling. Sine B over cosine B is tan B. By itself, it will run itself if you start with the right and correct step, correct logical step. Cosine A cosine B over itself is 1. Sine A over cosine A is tan A. Sine B over cosine B is tan B. You finished. Is that he wants. So if you start correctly, logically right, the main step was here is what? This must be 1 because he wants it 1. Simple like this in the formula. So you divide each term by this, you get the answer. To test yourself that you understood how to use this, I wrote the question for the students. They don't have the book. The students have the book. The question number is written here. Use cosine A minus B with A equals B equals theta. A equals B equals theta. To show that sine squared theta plus cosine squared theta equals to 1. All the basic trigonometric identity from P2. Second example. Another way or logic of asking. Express the following as single in terms of single sine, cosine, or tangent, which is question 9. We did, I'm choosing the parts. I choose solving the parts that it will help you to do the others. This is the main idea that I did today. All right, we are given expressions like the first one in part C. First part in this example, which is part C in the question in the book. Cosine 130, cosine 180, minus sine 130, sine 80. So cosine, cosine, so it's cosine. It's cosine. This is minus, so this is plus. Simple like this. So cosine 130, cosine 80 minus sine 130, sine 80 is cosine 130 plus 80, which is 210. We know from trigonometry in pure 12, cosine 210, cosine 180 plus 30. So the angle is in the third quadrant. 180, sketch it to you quickly here. This is the angle that we are doing, 30, in the third quadrant. So 180 plus 30 is 110. Since cosine is negative in the third quadrant, so this is minus or negative cosine 30. And we remember cosine 30 is radical 3. I did remind you already in the next example. with this. Why we don't just write this in decimal? Most of these questions come in the exams without calculator. Write the exact value without calculator. So you must remember them as I reminded you at the end of the lesson in a few minutes. Second one, or the second part, which is part H in the question, tan 2 theta plus tan 3 theta over 1 minus tan 2 theta tan 3 theta. This all equals to what? So remember, this is A, this is B. So since he added them, because I memorized the formulas, of course, it's your turn to memorize it by practicing. They will be given the formula sheet as well, but it's good to memorize them. It will help me to do the questions faster. So this is tan A plus tan B, so tan 2 theta plus 3 theta, so it is tan 5 theta. Finished. We wrote this as singleton. Next example, another way in asking, which is more difficult a bit. Given that tan x plus pi over 3, the radian form, is equal to half, show that tan x equals to 8 minus 5 radical 3. How do you prove this? We just tried, use the new formula for today for tan sum of two angles. So this is the first one. This is the second one. So tan the first plus tan the second, which is pi over 3 over 1 minus the formula. Tan the first, which is tan x, times tan pi over 3 is equal to half. Then we do just simple algebraic steps, as we know as A-level students. We know now tan pi over 3, which is 60. Tan pi over 3, it's radically 3. It's radically 3, and I did write again to remind you the triangles at the end of the lesson. In the next example, which is the last example for today. So here, if you use the calculator, yes, we need to show the steps step by step. But tan pi over 3 is radically 3 in here and in here. So you will get tan x plus radically 3 over 1 minus radically 3 times tan x equals to half. We do cross multiply. Cross multiply. You will get 2 times this, tan x plus radically 3 is equal to 1 times this. By expanding, now my dear students, by expanding, 2 tan x plus 2 radically 3 is equal to 1 minus radically 3 tan x. What does the question want? This is the most important. He wants tan x, the subject. So we collect the terms they have tan x. So 2 tan x plus radically 3 tan x, it will give 2 plus radically 3 tan x is equal to 1 minus 2 radically 3. By dividing both terms by this, both sides by this, you will get 1 minus 2 radically 3 over 2 plus radically 3. We remember from P1 or C1 for the core people, this is irrational, so I have to rationalize here. Rationalizing. We have to rationalize the denominator. So we multiply both numerator and denominator, the fraction, by 2 minus, this is plus 2 minus radically 3. By expanding, you will get 2 minus radically 3 minus 4 radically 3 minus 2 radically 3 times minus, so it's plus 2 radically 3, getting 2 minus 5 minus 1 radically 3 minus 4 radically 3 minus 5 radically 3 plus 6. 2 plus 6 now is 8 4 minus 5 over radical 3. Denominator now, common. Do you remember difference of two squares? 2 times 2 is 4. Radical 3 times it itself is 3. 4 minus 3 is 1. Getting the answer. So 8 minus 5 over minus 5 radical 3 over 1 gives us the result that he wants. Last example for today, to not make this lesson long. I planned for 7 pages, but we will do it in lessons. It's better to give you a chance to memorize and to practice more questions. We may find the exact value of sine or cosine or tan an angle without using the calculator. This I was talking about, so I reminded you here in the reference triangles. Using addition formula. As this example. This example, what does it want? He's saying show that cosine 105 degrees is equal to this. Show that, prove this in part A. Part B, show that secant 105 is equal to negative radical A times 1 plus radical B, based on part A, of course. So sometimes it's convenient to write hence here, and hence show that the second part. We know from P2 the exact values. If you don't know, I reminded you here. We know sine and cosine and tan for some terminal reference angles. And we get these reference angles from reference triangles. These two triangles. 30, 60, 90, and the isosceles one. And the isosceles one, the 45, 45. This is the main diagram, the main form for the triangle reference. If this side is x, and this is 2x, this is the ratios, these are the values of the sides. So getting from this triangle, sine 30 is equal to cosine 60, which is half. Yes? Sine 60 is equal to cosine 30 equals radical 3 over 2. Tan 30, opposite. Tan 30 over A, which is radical 3 over 3 in rationalized form. It's in simplest form. It's 1 over radical 3 from the triangle, but it is in the simplest form, radical 3 over 3, and tan 60 is this over this, gives you radical 3 over 1, which is radical 3. For 45, sine 45 is equal to cosine 45, because they are equal. So the opposite and adjacent, they are equal to this angle, gives you radical 2 over 2. From where they come from here? This is x radical 2, the hypotenuse of this triangle, which is 1 over radical 2. This is 1 over radical 2. In simplest form, it's radical 2 over 2. The same for here, 1 over radical 3 in rationalized form, radical 3 over 3. You must remember these things from AS. Using these two triangles, we can find, this is the idea in these questions. So what do? We write 105, dear students everywhere, is equal to 60 as sum of these two reference angles that we already know their exact values. Because of this, our main objective in this is finding the exact values. Because already we know the exact values for these triangles. We learned today the new formula, cosine sum of two angles is cosine the first cosine the second, minus sine the first times sine the second. We just replace or substitute the values from these triangles. Cosine 60 is half, cosine 45 is radical 2 over 2, minus sine 60 is radical 3 over 2, times sine 45 is radical 2 over 2. So we have 2 times 2, 4, common denominator. So what do you have here? Radical 2 minus radical 6 over 4, that he wants. Simple like this. Now secant 105, it's 1 over cosine 105. You know this from the previous chapter. Secant is the reciprocal of the cosine. So we just do the reciprocal for this. So it's 4 over radical 2 minus radical 6 by rationalizing again. So 4 times radical 2 plus, remember we have to converse the sign, it's a conjugate. It will give us 4 times radical 2 times radical plus radical 6 dividing by 2. 2 times radical 2 times radical 2 is 2. Radical 6 times itself is 6. So the denominator will be negative 4. 4 over negative 4 is minus 1. What did I do here only? I did radical 2 common factor. So put radical 2 common factor, you will get 1 plus radical 6 over radical 2 is radical 3 because he wants this form. It's not guessing thing, he wants it. So we did succeed in writing the result as negative radical A, which is 2, times 1 plus radical B, which is 3. This is our lesson for today. We didn't finish this lesson. We have to do more complex problems, more difficult problems in the next video. Even they delay the exams or cancel the exams for Excel. Even like they are announcing now, you'll be getting predicted grades or mock exams, marks. I don't know what will happen. Even this will happen, you must be involved in your material and your topics. At least for the university you are going, or your field, your specialization that you are studying. So you have to be ready, my dear students. I hope you find the lesson is interesting today. Hear from us soon in the next part of trigonometry in pure 3. Wishing you the best.